This is the first video for 8.3, so we are going to be talking about hyperbolas. Hyperbola is another one of our conics, and just like the others, we can talk about it as a locus of points that meet a certain criteria, right? So here's my graph of it, and when we did ellipses, we had two foci, and we were looking at the points that all were the same distance from the sum, right? It was the sum of the distances to the foci. We got an ellipse. In this case, we're talking about the difference. So here's my point, and if I take this yellow distance and subtract the blue distance, it always will turn out to be the same. And let me show you those. Here they are. Okay, so, got another one there. We use these. Okay, so the purple one is the one in purple, and the yellow one is the one in yellow, and then here it is, I subtract them. Okay, so you notice that although these are changing, the difference does not change. And it is true over here too. The sign changed. In reality, we would take the larger one minus the smaller one, and so it would always be a positive number. But that's how we get this, so that difference is always the same. So we could take those differences using the distance formula, and we could derive a formula, and this is what it would look like. Okay, so x squared over a squared minus y squared over b squared equals 1. Yeah, I know there's something under the 1, but I couldn't figure out how to make it go away, so it's got a 1. It's a 1 now. Here's our formula. What do you notice about this that's different from ellipses, right? It's almost the same. It's just that negative sign, right? So one of them is subtracted. Now, right now we're going to talk about the ones where x squared over a squared is the positive. And in the next video we'll talk about when y squared is positive. Okay, so when we have x squared positive, our axis, we'd call this the transverse axis, and it's kind of like the axis of symmetry, you know, where both sides are the same. It's the axis where the center and the vertices and the foci are all on that line. That goes along the x-axis. Right here, I have this little A0. This is a vertex. Okay, so, and this is the other vertex. So again, A is going to be, just like in the ellipses, A is going to be the distance from the center to the vertex. That's what A is. And C, you notice this time, C is bigger than A. It's farther, it's inside the hyperbola, right? And that's our focus. And there's the other focus. So from the center, we go over C, and we get the focus. We go back C, and we get the other focus. Just like with ellipses, right? Now, there's no actual width of this. It just keeps getting bigger. And so B is a little bit more difficult to picture than it was with the ellipses. But I made this so that I can change A and B, right? And in this case, it is totally, last time in ellipses, A was always bigger than B. This time, it's totally possible for A to be smaller. Okay, if A is smaller than B, turns up kind of like that. If A is larger than B, notice that it gets a little more compacted. If B is exactly the same, it could be exactly the same. And That was not true for ellipses. If they were both the same, we wouldn't have an ellipse, we'd have a circle, right? So, but in the hyperbola, it's okay for A and B to be the same. We tell which one is A and which one is B, not by which one's bigger, but by which one's on the positive fraction. Okay, so here's how we decide, and let me see, let me set this where we can, yeah, I'll make it come in a little bit. Okay, so here we have this ellipse, and A is 3, or close, and B is 2. Probably make it a little more exact. Well, not quite. Okay, so how do we draw B in here? We make a little rectangle. Okay, so A is the different distance from the center to the vertex, so that's A. And B would be how far we go up in our rectangle, right? So this side is the same as A, this side is B, and this side is B. Now, if I draw a line going through these diagonals, I get this line. This is an asymptote, and this tells you how wide your hyperbola will be. So B does affect it. And you notice that, see, as B gets, let me change B. As B gets larger, that rectangle gets taller and taller, so the hyperbola gets more flattened out and stretched up, right? As A gets bigger, it moves out, but it also narrows down. That's how A changes it. Okay, and I would have a matching asymptote going on the other side. Okay, now let's talk about the equation of this asymptote, because you'll have to find the equation of the asymptote. And I see these 2 points, right? It goes through 0, 0, or the center, and it goes through AB. So the slope of this line is up B over A. So the slope is B over A. The slope of the other line would be down B over A, right? So the slope of the other line would be negative B over A. So we have, now in this case, because our center is at 0, 0, the asymptote will go through 0, 0, and so there won't be any other y-intercept for our equation of our line. So we would write this in slope-intercept form as just the line. Since B here, we'll just say B is 2. It's pretty close to 2. Can't get it right exactly on. And A is, we'll say A is 3. So the slope would be 2 over 3. So this equation of this line would be y equals 2/3 x. And this one would be y equals negative 2/3 x. Okay, so that's kind of the relationship between these things on the graph, right? Now, if I give you the equation, you only know A and B, and so we need to be able to get C. But you notice this time C is bigger than A. A is not the biggest. C is the biggest. And it turns out, look at these 2 yellow lines here. This is the diagonal of the rectangle, and this is C. And I measured them. I have it measuring them, and I can move A and B, and you notice that they're always the same, right? That diagonal is C, and we could prove it. We're not going to have time. I'm not going to take the time to do it right now. We could prove that this is C, but I'm demonstrating it for you so you can remember. So that makes C the largest out of A, B, and C. And it's the diagonal of this rectangle. Okay, so that means that our relationship between A, B, and C, since C is the biggest, would be A squared plus B squared equals C squared. Okay, different than the ellipse. Right? It's not the same as the ellipse. It's C is the longest. In the ellipse, A was the longest. So A had to be equal to the other two added together, right? In this case, C is the longest. So we get this A squared plus B squared equals C squared. Okay, so that's how we set up this thing. Let's do a quick little problem so you can see how it works. Okay, here's my equation, and these are all the things I want to find. So for this section, the center is always going to be 0, 0. Okay, remember that the number under x squared is a squared. So it's 1, so square root of that would be 1. And the 4 is b squared, so that would be a 2. And then if you remember, we take a squared plus b squared equals c squared, because c is the largest of the three. And a is 1, and b is 4, b squared. And that means c squared is 5, or c is the square root of 5. Okay, now let's be sketching a little graph here. And we want to go from the center. Now x is first, right? So that means it's looking this direction. And from the center, I go over A. That's just 1. And I'm going to go up B and make a little rectangle there. Okay, so here it's up B and over A, right? And I end up with that asymptote going through there. And it'll be the same way on the other side, down B and over A. And I'll have that asymptote there. Okay, now the vertex, or A, remember, started right here. And we're ready, really, to sketch the graph, because it just goes through there and it approaches these asymptotes. You know, I look so wobbly, but... And there's our graph. Our vertices are from the center over 1 and back 1. Our foci are over C, which was square root of 5, and negative square root of 5, 0. And our asymptotes, the slope of that asymptote is b over a. So we have y equals b over a, so that would be 2 over 1, so that's 2x plus 0, because it goes to 0, so I don't need to write the 0. And the other one is y equals negative 2x. Okay, so that's kind of the basics of how we're going to do it. In the next video, we'll do some where it's turned, right, so that it goes the other direction, so the transverse axis is going up and down. So here's a quiz question for you that will just allow you to do some of this very same stuff. If you can't remember, come back to this problem we did. Alright, here's our quiz question. I gave you this hyperbola x squared over 9 minus y squared over 4 equals 1, and you tell me what A is, and then you name the vertices and write them as ordered pairs with parentheses, just like I did, just like I wrote them, and put a comma between them but no spaces.